Hello, everyone. So, this is the next lesson that talks about operations and polynomials. So, we're going to learn how to add, subtract, and multiply. Okay. So, the objective of this lesson would be for you to learn how to add and subtract polynomials vertically and horizontally. Also, you're going to learn how to multiply polynomials still vertically and horizontally, or sometimes they use it a box method. Okay. And then we're going to learn how to multiply using special product patterns. Okay. And the last one is try to do a bit of binomial expansion using Pascal's triangle. Okay. So first, let's do add and subtracting polynomials. Okay. So let's have an example. Suppose we add this to polynomials. So 3x to the third plus 2x squared minus x minus 7 and x cubed minus 10x squared plus 8. So the first method would be the vertical method. So just put one polynomial on top of the other. So that's going to be like this. Okay. So which means we just try to align like terms, x cubed, x squared, and then since there's no x, you just leave it as is and the numbers. Okay. And then we just simply add them. So 3x squared plus x cubed, or 3x cubed plus x cubed is 4x cubed. And then negative 2x squared minus 10x squared is negative 10x squared, since there's no this is just simply negative x and nothing here. Just simply put it down. And negative 7 plus 8 gives you 1. So this is going to be your final answer. Okay. Now you can also do horizontal method. Okay. So suppose we do the same thing using horizontal method. Okay. So we just simply all lie them down. Okay. And then after which we try to remove the parentheses. Okay. So since it's preceded by a plus sign, the signs doesn't change. So all we got to do is just simply connect terms that are the same, and then we get the same answer. Okay. So pretty much the rule is in adding polynomials, you must combine like terms together. Okay. Now let's go on to subtracting. Okay, subtract 2x to the third plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9. So it's going to be this minus that. So it's going to be, if we want to do vertical method, the 8x cubed should be on top first and then subtract it with the whole one. Okay, so that's why I put it on parenthesis. The easy way to do this is to just simply change the sign of the ones in the parenthesis and then change the operation to addition. Okay, so what I'm going to do is just simply just distribute and then change the sign to addition. So negative times 2x cubed is negative 2x cubed. Negative times 6x squared is negative 6x squared. Negative times negative x is positive x. And negative times 1 is going to be negative 1. So I just simply distributed the negative and changed the operation to addition. Okay, so if I simplify that, that gives me 6x cubed minus 9x squared minus x plus 8. Okay, you're going to get the same answer also if you do the horizontal method. However, just when you remove the parenthesis with the negative sign, the signs inside this change. So I get now this. So negative times 2x squared, negative 6, positive x, negative 1. And then you just simply combine like terms. Okay? So generally, the rule for subtracting polynomials is to subtract one polynomial from the other. Always add the opposite. So get the opposite and then you add. Okay? So that's how you basically add or subtract polynomials. So quite easy. Okay? So now, multiplying polynomials requires kind of like we can use distributive property. But in some cases, I use the box method. Okay? That is, I put them on sides of the box. So that's going to be negative x squared, 2x, and 4, and then this is x minus 3. And then I put the box between them. The intersections of the box, it's just simply the product. So x times negative x squared is negative x cubed, and this would be x times 2x is 2x squared. And then this is 4x, this is negative 3, and negative x squared, it's going to be positive 3x squared. And this is going to be negative tx, and this is going to be negative 12. And then just simply combine terms. So it's going to be negative x cubed. And then for x squared, I have 2x squared and 3x squared. It's going to be 5x squared. And then negative 6x and 4x, it's going to be negative 2x and then negative 12. Okay? So that's going to be my final answer. Okay? So I'm going to assume that you're going to work on these problems on your own, okay, while practicing. So I'm going to shift on to the next topic, which is actually special product patterns, okay? So this special product patterns is that you don't have to do the multiplication already because it's kind of special. You're going to know what the answer is already, okay? So it's in your textbook, okay? So I just put it in here. So basically there are three. Sum and difference of product. So a plus b, a minus b. It's going to be a squared minus b squared. So just simply multiply the first and multiply the second, as long as one is the opposite of the other. That's why you get x plus 3, x minus 3. Just multiply x times x gets x squared. 3 and times negative 3 is negative 9. Okay? So next one is the square of a binomial. So a plus b squared or a minus b squared. Notice there are three terms it's going to be. First and last terms will still be a squared and b squared. Okay? And the middle term would now be the product of the two. So it's 2 times a times b. So all you got to do is multiply this 3. Okay? So also here, that's why it's negative right there. Okay? These are examples that you can look up to. But we're going to discuss another example. Okay? And the last one would be the cube of a binomial. So a plus b, or a plus b raised to the third power, or a minus b raised to the third power. Okay? So it's going to be a cubed 3a squared b plus 3ab squared plus b cubed. So notice it's basically the same for both. It's just that the second and the last terms are negative if it's a minus b. Okay? So let's have an example. Okay? So use special products to find the product. Okay? So you get 4n minus 5 and 4n plus 5. So it's just sum and difference. Just multiply, square, multiply 4n times 4n, it gives me 16n squared, and negative 5 times 5, that gives you 25, okay? Now, next one is 9y minus 2 squared. So it's a square of a binomial. So first one, you square 9y, and then you square 2. And then the product would be, the middle would be the product of this, this, and this. So 2, 2, and 9y. So therefore, the square of the first one, and then the square of the last one, which is always going to be positive. And since this is negative, middle is going to be negative. And then you just have to multiply all the three. So if I simplify that, that gives me 81y squared. Okay. 2 times 2 is 4, times 9 is 36, and then 2 squared is 4. So it's going to be 81y squared minus 36y plus 4. Okay. And then the last one, it's a plus b, or ab plus 4 raised to the third power. Okay. So following the patterns, first you square AB, you cube AB, and then after that, you cube 4, and then each is the 3. It's already in the formula. So this would be AB squared times 4. Okay, so this is A and B. And this would now be 3. It's 3 is always part of the equation. And then after that, AB, and then you have 4 squared. Okay, so notice, as you go from term to term, the powers of AB decreases. So 3, 2, and then 1, and then there's none. And then the powers of 4 increases from 0, 1, 2, and 3. Then when you simplify, okay, you get now this. So AB to the third is a cubed, b cubed. And then 4 times 3 is 12, and AB squared is a squared, b squared. Next one is 4 squared is 16 times 3 is 48 times AB. And 4 to the third is 64. So all you got to do is simply follow, okay? This one right here. Always follow this, okay? You'll never get wrong, okay? Now, the next one that we're going to work on is how to work binomial expansion, okay? Now, binomial expansion is like when you expand a binomial by a power by a power, okay? It could be 2, 3, 4, 5, okay? That's why you have now this, okay? Now, it tells you that the numerical coefficients form like a triangle. So 1, 1, 1, and then you get the 2 here, it's 1 plus 1. You get the 3 here as 1 and 2. 1 plus 2 is 3. Remember, all the sides are 1. All the sides of the triangle are 1. Okay, and then you develop. Like this one, to get 10, you get 4 plus 6. It's going to go down. Okay? go down like a triangle, inverted triangle. So like the 6 here, you got it from 3 and 3. Okay. Your 4 here, you got it from 3 and 1. The 5 here, you got it 4 and 1. Okay. Now, notice here, okay, when you speak of Pascal's triangle, there are like a kind of general features when you expand. Okay. Now, the first term is that when you expand it, it will have n plus 1 terms, which means, like say, for example, if I have the power here as an n as 4, I'm going to have 5 terms. Okay. Or if I have, say, for example, a plus b squared, I get 3 terms. Okay. Now the powers of a, as I said earlier, so this one is kind of like the before was introduction, so I'm formally discussing it to you. The powers of a begins with n, okay, and then it decreases by 1 in each successive term and ends with 0. Okay, that's a here. Okay, it goes down, while b increases starting from 0 going to n, and then every term, the sum of the powers of each will always be equal to n. I'm going to show that to you, okay? Let's have an example. So which means expand x minus 2 raised to the 5th, okay? Notice that the power is 5, which means if n is 5, there will be what? 6 terms. First term would be x to the 5th, okay? And then the powers of x will decrease as we go from term to term. So notice as we started off like that, it's going to come up like this. So 6 terms, right? 1, 2, 3, 4, 5, 6. And then the powers of x goes down. Okay? It's not yet the final answer. I'm just explaining how it's done. Then you arrive at the final answer. So this one is basically how to do it. Okay? Now, look at the other one. So this is minus 2. So that's why negative 2, the power, will increase from term to term, starting from the second term. So starting from this, okay? So it's going to be from 1 going up to 6. So that's going to be something like that, okay? Or you could put negative 2 to the 0. It's the same thing. Anything to the 0 power is 1, okay? Just like this one. So I started from negative 2, 1, 3, and 2, negative 2 to the 3rd, negative 2 to the 4th, and negative 2 to the 5th, okay? Because it's the highest power right there. Notice it says that the powers of both, if I add, should be equal to 5, right? Like say 4 plus 1 is 5, 3 plus 2 is 5, the 2 plus 3 here is 5, 1 plus 4 here is 5. So basically, if I add up all the exponents, it's going to give me 5, okay? Now, let's go on to the numbers on the Pascal's triangle, okay? So I'll just simply copy that up, okay? So using Pascal's triangle, include the number of coefficients for 5, or listen to my technique. Okay? I'm going to teach you. Okay? Listen carefully. Okay? The numbers are the ones in blue. But how do we get these numbers? You can use Pascal's triangle, or you can do this. Okay? So the first one is always a 1. Always. Okay? It's always a 1. Okay? Now the next number, the 5 here, you see, would be the exponent of the first one. So you see that 5 over there? So if it's x to the 5th, the number here should be 5. So if this is x to the 4th, this should be what? 4. You get me? Okay. Now, to get to the next number, okay, this is how you do it. You multiply 5 by 4, the 4 the exponent, divided by the number of terms that you have so far with the number. So which means 5 times 4 is 20. How many terms do you have so far? 1 and 2. So 20 divided by 2, that gives me what? 10. Okay? That goes on to every term. Like say for the next term, multiply 10 times 3 is what? 30. How many terms do you have so far? 1, 2, 3. So 30 divided by 3 is what? 10. Okay? So automatically do that. 10 times 2 is 20. How many terms do you have so far? 4. So 20 divided by 4 is 5. And then the last one will also be what? 1. First and last is also 1. So once you do that, then you can just simplify everything up, because these are numerical simplifications. So that's going to be x to the 5th. This would be negative 2 times 5 is negative 10. This negative 2 squared is 4 times 10 is 40, positive. Negative 2 to the 3rd is negative 8 times 10 is negative 80. Negative 2 to the fourth is 16, positive, times 5 is 80. And then the last one would be negative 2 to the fifth, which is actually equal to negative 32. Okay? Remember, x to the 0 is also 1. So this is my final answer. Okay? Let's have another example. Okay, so expand 3y plus 1 raised to the third. Highest power is 3, which means it's going to be 4 terms. Powers of 3y decreases. Powers of 1 increase. So it's going to be something like that. Okay? So 3y to the third, 3y to the second, 3y to the first, and then there's none. And then the powers of 1 increases. So 1, 1 squared, and 1 to the third. Okay? And then we're going to put in the numbers. Okay? So automatic, this one is 1. This one will have what? The exponent, which is 3, right? And then we multiply. 3 times 2 is 6. 6 divided by 3 is 6 divided by 2 is 3 still. And then the last one is 1. So if you want, that's going to be it. So if I simplify that, this would now be my final answer. So 3y to the third is 27, y cubed. This is 3 squared is 9, times 3 is 27 still. Multiply that gives you 9y. And then the last one would be 1. Okay? So basically, that's how we work on polynomials. Adding, subtracting, and multiplying. Okay? So we'll end up for now.